Good morning, everyone. I'm Pat Ryan with the Public Affairs Office here at the Johnson Space Center in Houston. With me is Megan Levins. She is one of the senior robotics instructors here and is currently getting certified to be a robotics officer to work here in the Mission Control Room. Tell me real quickly about how you got interested in that area of work.
Well, I've always been interested in the space program, and who doesn't want to fly robots in space, so it seemed like the right place to go. I grew up in Hawaii where we have very clear skies and you get a really nice view of those stars at night, and it's inspiring.
Nice, nice. Well, we're ready to find out what you guys in Pennsylvania are interested in.
Hi, my name is Valeria, and my question is, how much training do you have to do to become a robotics engineer?
Well, to be a robotics engineer, there's a lot of training you go through. Once you get out of college or university and come to NASA, it's many years of training, and you start off with writing procedures for crew members and learning all you can about your robotic system before you can come into mission control and start moving the robots in space. So it's a long process, and there's lots to learn, but it's a very interesting one.
Hello, my name is Claire, and my question is, what controller would you call the brain of the Mission Control Center?
The brain.
Who's the brain?
That's a tough one.
A lot of people would say that that's the flight director. Flight director is the person who's in charge of the whole team. There's a team of 10, 20 people in here at a time, all of them looking at just a specific system. But they're all reporting to the flight director, who has to keep track of what's going on all of those systems all the time to make sure that the different components all work well with one another. But if I think it's not the flight director, it's probably the people who bring the snacks.
Hello, my name is Gabriel, and my question is, who is the most important person in the space station flight control room, and why?
Most important person would be the robotics officer, wouldn't it?
Always.
Yeah.
Well, I would say the most important person is probably the person that has the most going on at that time. You never know what can happen on a space station, so whether it's the robotic system or we have astronauts outside, whoever has the most information and knows what's going on is probably the most important person after the snacks.
Hi, my name is Emma, and my question is, if a crew member gets hurt or sick and they need surgery, is there always a doctor on board?
It is not always an actual doctor on board, but there is always one member of the crew who is trained as a medical officer. In some cases, you have a doctor or two doctors who may be on board at the time. And so far, we've been lucky enough that nobody has had to have surgery. But all of the crew members get trained in not only first aid, but also some more advanced things to take care of their crewmates just in case somebody does get hurt.
Hi, my name is Jessi, and my question is, do the teams switch on and off so that they can get sleep? If so, how does it work, and when do the teams take a break?
I think when the teams switch over might be one of my favorite parts of the day. We have about 3 teams that run in mission control every day of the week, all year round, even on Christmas. So luckily they only have to work 1 shift a day, and then the next shift will come on so we can all go home and get some rest.
So the day gets split up into thirds, really. So the teams that are here for about 7 or 8 hours in the room. They come in and they find out from the person in front of them what's been going on, then they take over. And then at the end of the shift, the next person comes in and you brief them about what's going on so that they can take over.
Hello, my name is Gavin. I would like to know, how long is your shift?
Well, as a robotics officer, my shifts are actually a little different than a lot of the other teamers. Like we said, when you're here all the time, your shift is roughly 7 hours, and then you pass off to the next person. For robotic shifts, we can go from 7 to 12 hours, depending on what kind of task we have for that day, and then we're off for the rest of the day. So ours may be a little longer, but we're not always here all the time.
Hello, my name is Bella, and I would like to know, what is your favorite and least favorite part of working at Mission Control?
Okay.
That's a good question. I have to say my favorite part is every time I get to talk to an astronaut in space. There's nothing like talking to somebody who you know is orbiting miles and miles and miles above you and doing some robotic task or another activity and getting to talk to them and get their thoughts and what they have going on in their day.
And in your job, you folks do get to talk to them while they're in the midst of these, of moving, flying these big robots around.
We do. For robotics, we do a lot of activities, free flyer captures when new vehicles are coming up, and then we also train for them as well. So not only do I get to talk to them about the activity they're doing, but also in all their training sessions as they get ready. I'd say my least favorite part is probably comes around 2 in the morning when you're still on console and ready to go home and it is way past your bedtime.
Hi, my name is Regan, and what is your favorite training exercise?
My favorite training exercise. Well, you know, here at JSC or Johnson Space Center, we have the neutral buoyancy lab. And in the neutral buoyancy lab, it's this huge pool with a almost exact replica of the whole space station, or at least parts of it. And they have a robotic arm that is underwater and can move around in this pool just like we do in space. So my favorite training exercise is when we get to go there and put a crew member in their astronaut suit in the water, and they're underwater and on the robotic arm doing activities, and I can fly the arm around with them on it. It's my favorite part of the day.
That's an example of what's going on in the neutral buoyancy laboratory. It's what it looks like from one of the cameras that the divers have, that they're floating around, making sure that the astronauts are safe, but also giving the instructors a good close-up look at what the astronauts are doing so that they can get better information and help the astronauts become better prepared to do those tasks when they get in space.
Hello, my name is Braden. How and when did you become interested in robotics?
I've been interested in robotics and more specifically the space station since I was a little kid. Well, in space since I was a little kid. Robotics has always been interesting. You know, I was always really excited for my math and my science classes, and those were my favorite parts of my school day. And from there, you go to college and you get to learn more about the robotics, and you build things with, you know, like you guys with your Lego robots, and it was just really fun, and I wanted to do that forever.
Hello, my name is Ella. My question is, did anything in your childhood inspire you to work with robotics and or NASA?
I was a big fan of my Lego set. Anytime you get to build robots with Legos, and then you get to do it on a much larger scale, it's pretty exciting.
Hello, my name is Alex. Can you give us any tips on what to study if we are interested in robotics?
I think you definitely should pay real close attention in your math and science classes. Those were the basis, and everything builds from there. So if you're paying attention and really studying up on there, and then when you get to college, you'll study math and science there, and it just keeps going.
Are there particular kinds of math or different areas of science that you found to be most helpful?
I mean, math is our universal language, so it applies. All kinds of math applies. Science-wise, it's the physics, all the engineering stuff, building things or getting to work with your hands, all of that applies, and where the basics of those.
Great. Okay.
Hi, my name is Maggie, and I would like to know what you find most interesting about robotics and why.
Most interesting about robotics. One of the greatest things I think about robotics is you are working and moving something that is miles and miles above you. I come to work every day and I get to move around a robot that I will never see in real life. I only get to see it through my camera views and my workstation. But here I am moving something, all over a space station that's miles away from me without actually ever touching it.
And that arm is huge.
It is. It's 7 meters, 11 meters. It's huge.
The main arm on the International Space Station is over 50 feet long. I don't remember how much it weighs on Earth, but it's
not small.
It'd go across this room.
My name is Evan, and my question is, working at Mission Control, how many experiments have you supervised and finished with all the data you were looking for?
Well, that's one of the fun things about the space station, and specifically robotics, is we help start so many experiments. I mean, we put the alpha magnetic spectrometer outside on part of the space station, and it's still, to this day, looking at the cosmic rays and how the universe is made. I don't know of any experiment that we've really completed. We just keep learning more and we keep going. And we get to work with, installing these new modules or free flyers like the Dragon vehicle from SpaceX and the orbital vehicles. And they bring more science experiments, so the science just keeps going. And we in robotics just help to keep all these experiments coming.
And it's a good example, too, because there's another one of those Dragon spacecraft that's supposed to be coming up to the station next week, and your arm is critical to
Yes.
To getting it there.
We will be capturing and installing the fourth Dragon, Dragon 3, on the 16th of April. We're very excited.
My name is Erik, and my question is, what is the most challenging project that you have worked on?
Gosh, I have to say the most challenging project I've ever worked on was when we first started capturing these free-flying vehicles. And the first one that came was an HTV from the Japanese Space Agency. And it was something that had never been done before and not something we had ever really looked into. And I got to help and be on the team that looked into doing this for the first time. And how are we going to train these crew members, and what are we going to do, and what does this operation really look like, all from scratch, all the way until it actually was captured that first day in 2009. So it was really nice to be on something all the way from the beginning and get to imagine it and see it played out.
And if you haven't done it, it's hard to imagine, because we're talking about a space station and another thing that are both moving at 5 miles a second. And you have to get them relatively so that they are still, so that you can reach out with a giant robot and grab the other thing. It's just that easy, right?
Right.
Hi, my name is Julia, and my question is, by what year would a manned mission to Mars be possible?
Go ahead. You in.
Oh, gosh, I don't know if I can put a year on that. I think it will be sooner than we all think, and I hope it's sooner than we think, and it will definitely be in one of our lifetimes, and who knows, maybe you could be the first.
Hello, my name is Erik Reed, and my question is, on what planets have you sent the rover to?
I know NASA has sent a few rovers to Mars, and I think Mars is the only planet we have sent rovers to. We also had manned rovers during the Apollo program on the moon, but Mars is our main target for our rovers.
My name is Martine, and my question is, how many robots have you built?
Well, on the space station, we have a few robotic arms. The Canadian Space Agency has 2, and there's the Space Station Robotic Manipulator, which is the arm I work with the most, and it's the one that helps with when our astronauts are outside and we have these vehicles coming up and captures them out of the sky. And then we also have the special purpose dexterous manipulator, and he does even small tasks with payloads and really fine, tuning things, and he works with different tools. And then the Japanese Space Agency also built a robot, and they have 2 robots up there as well.
Hi, my name is Madeline, and my question is, are there any robots that have a mind of their own, or are they all programmed?
Actually, I've worked for a couple of robots that had a mind of their own.
If they have a mind of their own, they haven't told me yet. They're very secretive. But most of them are programmed, but they're programmed so well you would think they have a mind of their own.
Hi, my name is Hannah, and my question is, how do you train for operations on the ISS?
Well, when I'm training to work in mission control, we do simulations, and we do it with the whole team, and it's really exciting because we'll, pretend to put the astronauts outside, and we'll have real crew members participating, and we'll look at all of our data and get everything just like it's the real day, but it's a simulation. And the whole team gets to work together and work through different scenarios that our training counterparts have come up with. Rescuing a crew member, or, our thermal system goes down, or, any kind of failure you might have in your house is just magnified on the space station, and we plan for it and train for it. So it's real exciting to get everybody together in a room and work through these different scenarios.
My name is Olivia, and my question is, what kind of instruments do you use?
Well, when we use a bunch of different instruments. When we do training, we have the virtual reality lab where our astronauts and And flight controllers can train where you actually put a helmet on, like a virtual reality helmet, and you can look out of this helmet and it looks just like you're on a space station. And there we have a robotic arm that we can drive around just like we do, and the crew member in their helmet can see it, and we see it in our simulated camera views. On the real day, we get telemetry to a computer very similar to how you can download books on the internet, and it just comes from space station, so we can see everything that's going on up there and look at where everything is. But the big thing is our cameras. We use a lot of cameras.
I believe that's the last of the student questions we have.
All right, and real quickly, this is Michael Hare at NASA's Digital Learning Network. Just wanted to see, do you guys have any additional ones maybe that weren't written down initially that you thought about as we did our first portion, or you actually connected with myself? Looks like we got a few hands.
Hi, my name is Isaac, and I would like to ask, what programming language do you use to program robots?
That is a great question. And I'm not actually on the program team, and I don't know the specific language. As I mentioned, the ARM is built by the Canadian Space Agency, and they took care of all of that for us. What we get to deal with a lot is more like what that looks like on our computer screens with the data that comes down and how it's already processed.
I see some hands in the back.
What language do they speak on the ISS?
It's a combination, actually. There is an official language, that's English. But right now, for example, you've got crew members who are from the United States and from Russia and Japan. And of course, they all speak their own native languages. Because they've been training together for a long time and working together to prepare for the flight and then fly it, they've all learned a little bit of all the other languages. And I've heard some crews say that they've really developed a language of their own. They can always communicate with each other through some combination of English and Russian. We also have European astronauts who fly, who bring a variety of their languages as well. So when they talk to the ground, when they talk to Houston, they're speaking in English, but they could be speaking in other languages when they talk to other control centers, too.
My name is Savannah. My question is, did your parents support you through what you wanted to do?
My parents were very supportive with what I wanted to do and encouraged me all through college and when I got the job here at NASA. The space station is very exciting, and my family was very excited when I chose this career path as well and supported me every step of the way.
Hi, my name is Olivia. I was wondering if you have a regular daily basis, and if you do, what is it? A daily schedule.
A regular daily schedule? Do you have a regular daily schedule?
We do and we don't. When there is nothing going on robotically on the space station, our day looks just like a normal work day where we come into the office and we work on our plans. When it gets really interesting is when we do have robotics plans, and those plans will go in and you find out about those weeks in advance so you can really prepare for them. And that's when you'll come in and you come onto console and you'll set up your workstation so you can see all the telemetry and the data that you need for whatever task it is you're doing that day, and review the operation that you'll be doing that day, and then actually execute it. And you'll go through your shift and execute your procedures or whatever plan it is that you have in order to complete the task that you're doing, whether it's a free flyer capture or a science experiment or working with the special purpose dexterous manipulator. All of those activities you'll go through and plan, and then at the end you'll review your data, make sure you have everything ready for the next team before you hand off.
Hello, my name is Aiden, and my question is, how long do you expect the International Space Station to stay livable?
How long will it stay livable? The partners have recently made an agreement to extend the life for another 10 years. That's to 2024. I think that there's some thought among some people that with the right kind of work, it might be able to fly for even longer than that. But right now, we're looking at the station flying until 2024.
Hi, my name is Jenna, and I was wondering what college you went to.
I went to the University of Nevada in Reno, and it was a great college.
When you're on the space station, what time zone do you use?
Well, the space station uses Greenwich Mean Time, which is a little different than Houston time and can change periodically.
Change back, and Greenwich Mean Time is essentially the same as London, because the control centers for the station are located all around the world, so they had to pick just one time to operate on. So on board, it's Greenwich Mean Time, which right now is 5 hours ahead of Houston time.
Hi, I'm Michael, and do you think NASA has the technology and robots to search the water for the missing Malaysia airplane?
It took longer for that question to come than I thought. I think if NASA has the technology to do it, they would be doing everything they can to try to find it. And they are doing everything they can.
I know we have been using some of the cameras on board the station to take pictures of the search areas, and they have contributed in that way.
Hello, my name is Elissa, and I was wondering if there is a problem with the connection, if there is a problem with the connection to the people on the ISS, who would you talk to fix it?
Well, it would be a combination of our communications experts here on the ground as well as our astronauts on board. You can believe if we've lost communication with our space station for any reason, everybody is trying to recover it, and they'll be looking on both sides, both on the space station and here on the ground, for what could possibly be the reason and fixing it.
Hi, my name is Colby, and why is the International Space Station shaped the way it is?
Why is it shaped the way it is? A lot of it has to do, it wasn't, I don't think they started off thinking, let's have a station that looks like this. It looks like it does because the components are built to serve a purpose. It's got these giant solar array wings out there because they need them to generate electrical power that runs everything on it, for example. And so, I mean, if you were flying through the air, that wouldn't be a good shape. When you're flying in orbit, the shape doesn't matter. It's not a question of moving smoothly through the air because there is no air. And all of the rest of the components of it, too, are built with that in mind. That along with the knowing that they had to be a certain shape in order to fit inside the space shuttle or Russian rockets in order to be launched. We couldn't be much bigger than that in terms of the cylinders because they wouldn't have fit inside the shuttle in the first place.
And Corpus Christi Catholic School, this is NASA's Johnson Space Center. This is the Digital Learning Network. It looks like we've run out of time, so I wanted to see if you want to say any final words, maybe a teacher speak up, and thank our very special guests in Mission Control for actually connecting for this live educational event.
On behalf of Corpus Christi Catholic School, we'd like to thank you for taking the time out of your day to talk to our students. I know they were looking very forward to this, so thank you very much.
Thank you so much for your question.
You're welcome.